So just like you saw in that example before, whenever we want to find the equation of an inverse, what we're going to do is we are going to switch x and y, then solve for y. And we have to be a little bit careful of the language in these questions, because sometimes they're going to say, like this one, find the equation of the inverse, and sometimes they're going to say find the inverse function. Now this one we can do, find the equation of the inverse. This one, if the question said find the inverse function, it wouldn't necessarily work because the inverse isn't a function. So we're going to look at this one. When we have y equals negative x squared plus 4, what we need to do, move the 4 over, divide by a negative 1 to get x squared by itself, and then square root both sides. When you square root both sides, you're going to get plus or minus. Are you all right when I divide by that negative 1 that I write negative y plus 4? Dividing both the y and the negative 4 by negative 1. We're going to color code this. So this is where our transformations come in handy. If you were graphing negative x squared plus 4, our parent graph is a parabola. What would the negative do? Flip it down. And then the plus 4, move it up 4. So it's going to look like over 1, down 1. It looks like that. Now, when I switched x and, sorry, did I switch x and y? No, I haven't done that yet. So I solved for x, but I forgot to switch x and y. So normally you switch x and y right at the beginning. So I could change all my y's to x's and x's to y's. So I could do this, change this to a y and this to an x and solve it, and then I'd get y equals negative x plus 4. Or you can do it at any time. So if I did it at the end now and switched x and y, I would get that. Personally, I like to switch it right at the beginning. I don't know why I forgot. What kind of graph is this? Well, we would have to do positive and negative. You would do it once positive and graph it once with the negative. Let's look at the positive one first. What's our parent graph? For negative square root of x, negative x, sorry, plus 4. What's the basic graph that starts with? Square root graph, right? What kind of transformations do we have? 4, we got a reflection, and 4 to the left, right? I see lots of nodding. All right, good, because we forgot something. We made a special note the other day. Our special note said, whenever we have a horizontal stretch, reflection, or compression with a horizontal translation, we have to factor first. So this equation should actually be written like this. And it will actually be moved 4 to the right instead of being moved 4 to the left. So if I took my square root graph, and inside I have a negative, that means it's going to flip over the y-axis and then move 4 to the right. I'm going to get this point. And then I'm going to get this point. Nope, sorry, I'm going to get, this is bad. Dot away. That's going to be that graph. And the second one would flip it over the x, then flip it over the y, and move it 4 to the right. And go like that. Now I graphed the green one by looking at my two equations. You could have also graphed your green one by looking at your original graph. Notice you have the point 0, 4. If you switch x and y, you're going to have 4, 0. So is it possible you could forget to factor out the negative and move it the wrong direction? As you guys demonstrated, yes, that is quite possible. Okay? So sometimes having that double check, did I switch my x and my y value, is really helpful. Because if you would have moved it 4 to the left instead, you would have gotten a point that didn't match up with the original graph. And same thing, some other points you had, 2, 0. Now you have 0, 2. You have negative 2, 0. Now we have 0, negative 2. But our inverse isn't a function. So part A, determine the equation of the inverse. It has a plus or minus. Part B, we sketched both graphs together. Is the inverse a function? In this case, no, because it doesn't pass the vertical line test. At the bottom of page 239, there is this question. When is the inverse of a function also a function? What would have to happen to our original function so that our inverse is also a function? Like our parabola, when we did the inverse of that, we got a sideways parabola, and it wasn't a function. How could we tell, just looking at our parabola, that the inverse wouldn't be a function? It's going to flip it, yeah, over the left or right. So if you sort of turn this, yeah, there it is. So the original function would have to pass a horizontal line test. All right, questions for this one are 5 and 6.